Artificial intelligence can now write essays, generate images, translate languages, and even help doctors analyze medical scans. At times, it almost feels like these systems understand the world the way humans do. But there's one surprising fact behind nearly every powerful AI model. It was trained using enormous amounts of data. We're not talking about thousands of examples. In many cases, AI systems are trained on millions, billions, or even trillions of pieces of information. Entire libraries of books, articles, images, and conversations may be used just to train a single model. So why does artificial intelligence need so much data in the first place? Why can't we simply teach a machine the way we teach a person? To answer that, we first need to understand how AI actually learns. Artificial intelligence is quickly becoming one of the most important technologies of the modern world. It powers recommendation systems on streaming platforms, helps detect fraud in financial systems, and assists scientists in analyzing massive data sets. AI is also transforming industries such as healthcare, transportation, and manufacturing. Self-driving cars rely on machine learning to understand road conditions. Medical imaging systems use AI to detect patterns that might be invisible to the human eye. But behind all of these impressive capabilities lies a common requirement: data. Every AI system must learn patterns before it can make predictions or decisions. And the more complex the task, the more examples it typically needs to learn from. In other words, data is the raw material that allows artificial intelligence to improve. Unlike humans, machines do not learn through intuition or personal experience. Instead, most modern AI systems learn by analyzing large collections of examples. Imagine teaching a computer to recognize cats in photos. 1 or 2 images would not be enough. Even 10 pictures would barely help. But if the computer analyzes thousands or millions of images labeled cat and not cat, it can begin to detect patterns. It might learn that cats often have pointed ears, whiskers, and certain facial shapes. These patterns allow the system to make predictions when it encounters new images it has never seen before. This process is known as machine learning, and the accuracy of the model often depends heavily on how many examples it has studied. The real challenge is that the world is incredibly complex. A single concept can appear in countless different forms. Take language as an example. The same idea can be expressed using different words, sentence structures, or cultural references. Even small changes in context can dramatically alter meaning. For an AI system to understand language well, it must be exposed to a huge variety of examples. The same is true for tasks like recognizing objects in images or understanding human speech. Lighting conditions, camera angles, accents, and background noise can all change the way information appears. Because of this complexity, AI models require vast datasets to capture the full range of possible variations. The more diverse the data, the better the system can generalize to new situations. Modern AI models are essentially powerful pattern detection machines. They analyze data and search for statistical relationships between different pieces of information. For example, a language model might learn that certain words frequently appear together in sentences. By analyzing billions of sentences, it begins to understand how language is structured. But detecting subtle patterns often requires enormous amounts of data. Some relationships may only appear rarely, and the model must see many examples before it can learn them reliably. Large data sets also help prevent errors caused by unusual or misleading examples. If a model only sees a few samples, it might learn incorrect patterns. By studying massive data sets, AI systems gain a more accurate understanding of how information is typically organized. Another reason AI models require large data sets is the structure of modern neural networks. Many advanced AI systems contain millions or even billions of adjustable parameters. These parameters act like tiny tuning knobs that allow the model to represent complex patterns in data. During training, the model gradually adjusts these parameters to minimize prediction errors. But learning the correct settings for millions of parameters requires enormous numbers of examples. Without enough data, the model may simply memorize the training examples instead of learning general patterns. This problem is known as overfitting. Large datasets help ensure that the model learns broader rules rather than specific cases. The scale of modern AI training is truly enormous. Some of today's largest models are trained on datasets containing hundreds of billions of words or images. These datasets may include books, scientific articles, websites, conversations, and many other sources of information. Training such models requires powerful computer clusters running for days or even weeks. Massive data centers perform trillions of calculations as the model gradually learns from its training data. While this process can be expensive and energy-intensive, it allows AI systems to achieve levels of performance that were unimaginable just a decade ago. And as datasets grow larger and more diverse, AI systems continue to improve. At its core, the reason AI models need so much data is surprisingly straightforward. They learn by observing examples. More examples reveal more patterns. More patterns lead to better predictions. Large datasets allow AI systems to handle the complexity of language, images, and real-world information. Without enough data, models struggle to generalize beyond the examples they've seen. But with enough data, computing power, and carefully designed algorithms, machines can learn to perform tasks that once seemed uniquely human. Artificial intelligence may look like magic from the outside, but underneath, it's built on a simple principle: learning from massive amounts of information. And in the world of AI, data is the fuel that makes it all possible. Thanks for watching. Don't forget to like, subscribe, and stay tuned for more explanations of the fascinating technology shaping our future.